ठीक है।
गुड मॉर्निंग स्मार्टी।
गुड मॉर्निंग।
करें शुरू। चलो कर ही देते हैं। ओके सो आज today we are going to show you one of the most unique softwares available on internet. It's called NASA's eyes, and we'll show you a few satellites orbiting Earth today through this software. Okay, so let's start. Eyes on Earth. Aryan, is the screen is visible?
What?
Can you see the screen? Hello. I think you can see the screen. It will take some time to get loaded. Here is our beautiful planet. So we'll tell you about some orbits and few satellites which are in those orbits. And there is one very special satellite which we'll look on very closely today. So this is how our planet looks like. If you could see those satellites and you go out and you can see those satellites, you'll see something like this. Actually, these are just the American satellites, and that too few renowned satellites. There are many more satellites, like all nations, like be it China, Russia, India, Japan, UAE, all these, be it European Union, all these agencies have been sending the satellites over past few decades. And here is the sun. There you have the sun. Moon will be somewhere in the opposite direction, obviously. Okay. On Zoom, it's lagging a bit. I don't know why it runs smoothly when I don't share the screen, but now it's lagging. Just a minute, people. Let me just close a few software. Yeah. On the second monitor, we have some heavy software open, so I've closed that. Now it's running fine. So you can see there are a lot of satellites over here. Can you see that a lot of satellites are just moving like this? See this thing. Can you see this orange colored band? Let me just catch one of those satellites. Let's catch this. Cygnus. Can you see this satellite? It's moving perfectly as if it's moving through equator, though it's not equator. It's in Jammu Kashmir region of India, so it's obviously not equator, but it's moving at a perfect circle, a perfect circular motion horizontally throughout the Earth. See? So these are Cygnus satellites, and this particular orbit in which they are moving, it's the geostationary orbit. Is it? Let's see. Now the characteristic of geostationary orbit is that it's it's like the satellite's relative position around the Earth does not change. Like if you deploy it over the Indian subcontinent or over your country, then it will remain in that position. Its position will not change. Means that it moves around the Earth at the same speed at which Earth moves on its axis. Okay, so that's why the orbit is called geostationary. Means that it's a stationary orbit relative to the Earth, which is called as geo, not the network service provider geo. Obviously, the geo from geography. Now, Cygnus, I'm not aware of this satellite whether it's geostationary or not geostationary, but through its motion, we can see that it's the landscape below us is changing very quickly. So we can make a very logical guess that this satellite is not geostationary, neither geostationary nor geocentric. It's most probably in the low Earth orbit because you can see it's moving at a very fast speed. So I I use this satellite because let me just move to the planet. Okay. So I have used this satellite because to explain you because this software all the satellites are either in equatorial low Earth orbit or polar low Earth orbit. There are hardly satellites which are in medium Earth orbit or the geocentric position. You cannot see GPS satellites, I guess. Yeah. So there's Cygnus, but if you just move around this position where the Cygnus is moving, if you move just a bit higher in radius above the Earth, then you will get the geocentric orbit over here. A very a fact is that the Indian GPS, not GPS, exactly the Indian navigation system, Bhuvan, it is a geocentric. It's based on geocentric orbit. Means that the satellites in the Bhuvan system of navigation, they are in geocentric orbit. Means their relative position is always over India and India subcontinent. So it's like there are satellites which can see this entire region, and their position does not change. So that saves a lot of fuel and energy also as well. Now we'll look at one example of a satellite known as Landsat. Landsats are purely polar satellites. These are used for imaging, like all those images you see of planet beautiful Earth images. The Landsat provides those images. Here you can see Landsat 7 uses powerful sensors to capture stunning images of Earth's surface and reveal some of the effects of global change. So this is how a Landsat satellite looks like. It's also in a type of lower Earth orbit when it's in polar orbit. Now what is polar orbit? The polar orbits are those orbits which move over the poles of Earth. Like you can imagine the Cygnus was moving in horizontal. Like if you want to imagine, you can just imagine it like as if the Cygnus are moving on a table. If you have a table and it's the Cygnus are moving on table, and that surface of table is the mid part of the Earth. But these Landsats are moving in and out of the table. You can imagine that one is moving horizontally on the table and one is moving vertically. Okay, so that's how Landsat satellites are. They are in the polar orbit. Polar orbit has this one speciality that this, the movement is very fast compared to the equatorial orbits. The polar orbits, satellite moves faster than equatorial orbits, and I would like to tell you as a fact that it's difficult to launch satellites to the polar orbits. Relatively compared to the equatorial orbits. It's easier to launch satellites to the equatorial orbit, and it's a bit difficult to launch satellites to the polar orbits. And there are also different rocket launch sites which are designed specifically for launching polar orbits. Have you heard about Vandenberg Space Launch Facility? It's in US, or like it's I don't know, it's West Coast, I think. I don't know which coast it is, but it's most probably on West Coast. So you can know that the relative position of the satellite on that part. The Vandenberg Air Force Base, or which is also used as a space launch facility, that region is specifically designed to launch satellites to this particular orbit. A lot of spy satellites are in the polar satellite region because it's hard to reach to that region and you cannot easily detect a satellite in polar region. You saw it was South America. We passed over South America just now. This is Antarctica. So this is the polar Earth orbit. That was the Cygnus were in equatorial low Earth orbit. All the satellites are in low Earth orbit, which means they are above the Kármán line, over the Van Allen belts, and not too high. They move relatively very close to the Earth's surface. The International Space Station, for example, is in low Earth orbit and it moves 400 kilometers above the surface of Earth. Microgravity region. you can call it. Now we'll move to the special, you can call it a special satellite of today for the day. It's not actually a satellite, it's a whole system, a human system in space. The only place where humans live in space is the International Space Station. Let me find the International Space Station. Just a moment.
That's ISS.
I know that's ISS. Here it is. You know, Aaron, when I was like 2 or 3 years ago, when I was about 12 or 13 years old, I used to go to my nanny's house, and there I used to watch the sky, okay, stargazing type of thing. So a lot of times I saw one very, very bright red colored light which used to come from a direction and then always disappeared in a direction. It was like a moving star moving very fast. Like within a minute it would disappear. I was very curious for few years and what is this red colored light which I see, and it used to pass at the same time. So I think last year or last year I got to know that it's the International Space Station which can be viewed from India. This is the position of International Space Station. This is a very big system. You can see this is a very large system, and obviously it will be large because it's a lot of nations are have combined their efforts into this, as well as this place. This place is a place where humans live on in space. So let me just compare the size. Like you all have seen the school bus. What if we place a school bus over here near to it? You will get the idea of the size, as large as few football grounds, few cricket grounds. Okay, so where is our bus? Here is the bus. If
I think
this
ISS was launched in 1998.
you're right. You can see if this is the school bus, then this entire system. Can you imagine how big this is? The solar panels are larger than many buses combined. So that's the comparison of size. We'll not compare it to a scientist, obviously. It's
Very huge.
huge. It's very huge. There are various systems in this, like we have Cupola, we have various, and this is not the American space station. It's not made by America. Many people think it's only American. It's Russian, American, European. But this part, can you see? Arun Kumar, can you see this a bit gray colored part? This is Russian module. This was provided by Russia. Okay, this part is the American module. There are two modules inside a space station division: a Russian module and a American module. Now, International Space Station. These things. Do you see these things? These solar panel-like things which are protruding outward. These are radiators. They radiate heat, the heat of the system out into the space, and these are the solar panels. Now there are various parts. There are station modules, habitation modules, fuel tanks, all those things. But we'll not go that much deep into it today. So this is in just the International Space Station. Now, International Space Station is placed in a very unique orbit. It's still, though it's the low Earth orbit, it's 400 kilometers above the Earth's surface. But I will just show you where this moves, and I will tell you the significance of this orbit. Why International Space Station is placed the way it is. Can you see International Space Station anywhere? It gets lost very easily. Hmm, okay, International Space Station. Where are you, ISS? Where are you? Oh my god, it's lost.
It's lost, I think.
Here it is, here it is. See, it passes over India. Its trajectory increases. It passes through Vladivostok and parts of China, and it passes, then it moves on to miss the entire United States. Can you see it missed the entire US? That's the trajectory for 30th September, obviously. its trajectory changes a bit. Okay, we are in Uttar Pradesh of India, Uttar Pradesh. So not daily, but occasionally we also see a satellite, this International Space Station. You see, now it will pass through Uttar Pradesh. See, it passed through Uttar Pradesh. If we were outside, we would have seen this satellite. Now it passes through Russia. Now the reason behind this thing was that US had a launch facility. I had told you previously about the polar launch facility of US in Vandenberg, somewhere in this region, and the Kennedy Space Center. The Apollo missions, from where the Apollo missions took place, is here in Florida. Now it's a bit difficult for rockets to launch to International Space Station from US. A bit difficult, not too difficult. Their rockets are very powerful, so they can do this. But the main reason was that after 2011, for a lot of years, US was not able to send their astronauts to International Space Station on their own rocket because they had no rocket which had this capability. The only rocket at that time in the world was the Soviet era Soyuz rocket, not the Soviet era exactly, because they had modernized the rocket very well, but the design was same, still same. So,
I think recently SpaceX designed a new
yeah,
launch vehicle.
yes, yes. After 2011, this year only they have sent new like American astronauts from American soil. Russian now Russia used to launch. Russia's launch facility is here. Can you see Kazakhstan? It's in this part, the Kazakhstan region.
Yes.
Uh, one of the very famous one of the very famous pad launch pad over there is the Gagarin start. See, it passed over the Kazakhstan region. Gagarin start. There is a very beautiful spaceport in Kazakhstan region because it was a part of Soviet era space missions. So international, that's to just to comply with the Russian Soyuz launch facilities. ISS has a trajectory like this, and it passes through India as well. So Aryan, what do you think? I think in future India will also send its missions to International Space Station. Huh?
Yes.
Gaganyaan might go to International Space Station someday, not the first one, obviously.
I think it will launch in 2022.
Gaganyaan will go, but I think someday India will also send its astronauts from its own rocket to International Space Station because ISS passes through India a lot of times, and there we have nasty country. Array, let's leave. We don't want to make the video political. So this is a very beautiful software designed by NASA. It's called NASA's Eyes on Earth. So I'll summarize the video in few lines. Can you see this part? I will move the cursor in this part. This part. Here, if you go beyond this line, like if these satellites are moving very close to the Earth, if you go a bit far in this region, you will get the geostationary orbit, which means any satellite which is placed in this region. Let me annotate the screen. Just a minute. If any satellite is placed in this region, like a bit far away on around I think 36,000 kilometers above the surface, if any satellite is placed in this region, then it will move with a speed relatively stationary with the Earth because Earth is moving on its axis, and the satellite will also revolve around the Earth at the same speed at which Earth is moving on its axis. So that means that the relative position of the satellite will not change with time. If we see, this is the low Earth orbit, this entire region. There is a medium Earth orbit, this entire region. Let me just show the low Earth orbit in another color. Not exact, it's not zigzag, obviously, it's not zigzag. I'm just showing the region. Like you can imagine, there is a around the Earth, there is a small sphere, and there's a very big sphere. The big sphere is the medium Earth orbit, and the small sphere is the low Earth orbit. Medium Earth orbits are used by GPS in their technology, but the Indian navigation system uses the geocentric orbit, basically, essentially. Now, in the low Earth orbit, some satellites move around the equator, in and around the equator, like these satellites, ISS, even ISS. These satellites have they change their path slowly, because you can see when we started the program, the Cygnus was moving perfectly in horizontal position. Now it has dipped a bit. That happens just to accommodate the change in trajectory. And these are the equatorial orbits in which satellites move at a relatively slower speed than the polar orbits. And polar orbits are basically these orbits. Can you see? Terra, Griffiths, be it the Landsat imagery system, Landsat satellites. These are in polar orbits. Most of the spy satellites and imaging satellites are in polar orbit. In polar orbit, the velocity of satellites is strong, is like it's more than compared to the equatorial orbit. It moves relatively faster. And these were the orbits. Let me rotate it once more to show you. Yes, so these orbits, like here, these are the polar orbits. And if it moves around somewhere around here, then it's equatorial orbit. So I hope our video was clear today. This is for the first time we are trying a video like this on our channel. Please like, share, and subscribe. Stay tuned for more videos, and we'll improve our quality in the upcoming video whenever it will come. So for that time, stay tuned. We'll be back very soon with another video in which we'll explore the solar system similarly. Okay, so bye bye.